This is one of those questions that I actually get asked quite a lot. You have to talk about resistance and current and voltage, but it helps an awful lot if you can actually understand what electricity actually is. Now, like most things in science, we're going to use a model to talk about what electricity actually is, and like most models, it's not perfect. It doesn't explain every detail, but it gives you a good mental picture to build your ideas around. So, imagine that this is a piece of wire made from, well, copper, for example. Now, it's made up of some positive metal ions. Now, I'm not going to draw them all in, mainly because I can't be bothered, but those metal ions are ions because some of their electrons aren't too tightly attached. And those are called free electrons. Those free electrons will happily sit in the metal, being attracted by the ions round about them, and that force of attraction holds the metal together. That's what a metallic bond is. So if we come along and we put a huge big potential difference across there, in other words, we apply voltage, well, we know what opposite charges do. Those opposite charges will attract. Why? Well, they do, and those electrons get attracted away from those positive ions because this is a much bigger positive charge than this one. So, those electrons will try to drift through the metal. Now, that electron drift can be measured. Okay? So if we measure the rate of movement, well, that's something we can measure. Great. We can also measure how much energy is carried. So what? Well, if we're talking about electricity, we don't talk about individual electrons. We talk about a whole group of electrons at once. And we talk about charge rather than just individual electrons. So we talk about a coulomb of charge. Yeah? So instead of talking about the rate of movement of individual electrons, or the amount of energy carried by individual electrons, we talk about the rate of movement of a coulomb of charge, or the amount of energy carried by a coulomb of charge. So, if we have one of those, 1 coulomb per second, well, there's our rate of movement, and 1 coulomb of charge passing any given point in this conductor in 1 second equals 1 amp. So when you measure current and you measure an amp, that's what you're measuring. You're measuring how many coulombs of charge pass a given point, and that given point is your ammeter, in a circuit. So if we think about the amount of energy carried by that coulomb of charge, we can measure that too. And 1 joule of energy per coulomb of charge equals 1 volt. So we can now use our model to talk about what current and voltage actually are. And by the way, you can use this model to talk about resistance as well, because as these electrons drift past the positive ions, well, they feel a little bit of drag from that positive charge. And that drag, well, that means that not all of that energy goes into moving the electrons. And some of that energy from this drag gets given out as heat. And so, that's why resistance in the electrical circuit generates heat. And you can use this model to talk about resistance too, but most of the time we use it to talk about those two ideas. So now you know what electricity actually is, and you know how you can use this model to talk about current and talk about voltage, and what each of those units actually means.